Everything you thought you knew about living fossils? Complete fantasy. Deep in the ocean, there's a shark that shouldn't exist. A creature so alien, so utterly wrong that when fishermen first hauled one up in 1898, scientists thought it was a deformed freak. Pink skin, protruding snout like a fleshy blade, and a jaw that does something no other shark's jaw should do. It shoots out of its face like a xenomorph from Alien. For over a century, we cataloged this thing as a curiosity, a rare deep-sea oddity, slow, primitive, harmless, a leftover from the age of dinosaurs that somehow forgot to evolve. Turns out, we were catastrophically wrong about almost everything. The Goblin Shark isn't slow. Its jaw strikes at 3 meters per second. It isn't rare. We just never looked in the right places. And it isn't primitive. It's hyper-specialized, a precision-killing machine that's been perfecting the same terrifying hunting strategy for 125 million years. But here's what'll keep you up tonight. We've seen this creature alive maybe 50 times, total. In all of human history, we've captured a handful, filmed even fewer, and every single time we study one, we discover we were wrong about something fundamental. Its speed, its senses, its habitat, even how many exist. Because the Goblin Shark isn't just rare, it's deliberately invisible, living in a part of the ocean we can barely reach, hunting in ways we're only beginning to understand. Let's rewrite the textbooks. I'm taking you into the abyss where this nightmare evolved. We're uncovering what the Goblin Shark really is, and exposing exactly how scientists got it so spectacularly, embarrassingly wrong for so long. Picture this, 1898. A young shark is pulled from deep water off Yokohama, Japan. The fisherman who catches it immediately knows something's wrong. The skin is pink, not gray, not blue. Pink, like raw flesh. The snout extends forward like a fleshy sword, flat, blade-like, covered in pores. The teeth are visible even with the mouth closed. Long, needle-sharp fangs jutting at odd angles like broken glass. The fisherman sells it to a local collector, who sends it to American zoologist David Starr Jordan. Jordan examines the specimen and realizes he's looking at something that shouldn't exist. This shark doesn't match any known species. It doesn't even match any known family. He names it Mitsukurina ostoni, the Goblin Shark, after the Japanese Tengu demons from folklore, creatures with elongated noses and supernatural powers. The name fits, because this thing looks supernatural, like something that crawled out of a Lovecraftian nightmare. For decades, that single specimen is all we have. One dead shark. No context, no behavior, no understanding of where it came from or how it lived. Just a bizarre corpse in a jar that scientists occasionally point to and say, yeah, that's weird. Then in 1985, something changes. Fishermen off Taiwan start pulling up goblin sharks. Not one, dozens. All from depths between 200 and 1,300 meters. All pink, all with that horrible protruding snout. Scientists finally have enough specimens to study. They dissect them, measure them, analyze their anatomy, and reach a conclusion. This is a living fossil, a relic from the Cretaceous period that's been coasting on evolutionary momentum for 125 million years. Unchanged, unspecialized, basically a swimming dinosaur. We were so wrong. Fast forward to 2007. A Japanese film crew working with researchers manages to capture footage of a living goblin shark in its natural habitat. The shark is suspended in the water column, barely moving. Drifting. It looks sluggish, harmless, exactly what we expected. Then it feeds. The jaw explodes forward. It happens so fast the camera can barely track it. One frame the shark looks normal, the next frame its entire mouth has projected 9 centimeters out of its head, grabbed the prey, and retracted back into place. The entire strike lasts less than a third of a second. Scientists analyze the footage frame by frame. They measure the speed, calculate the force, and realize something terrifying. The goblin shark's jaw moves at approximately 3.1 meters per second during a strike. That's faster than most sharks can swim. This isn't some slow, primitive scavenger. This is a precision ambush predator with a biological weapon no other shark possesses. Here's how it works. The goblin shark's jaw isn't fixed like ours. It's slung beneath the skull on elastic ligaments. When the shark strikes, specialized muscles release tension like a spring-loaded trap. The jaw shoots forward, extending far beyond the shark's head. The teeth close around prey. Then the jaw retracts, dragging the meal into the shark's mouth. The entire mechanism is mechanical, efficient, terrifying. And it gets worse. Those teeth aren't just for show. They're long, thin, and incredibly sharp, designed to pierce and hold soft-bodied prey like squid and fish. But they're arranged in multiple rows. When one tooth breaks or falls out, the row behind it shifts forward, like a biological conveyor belt of knives. The shark can lose teeth constantly and never lose its ability to hunt. It's a self-repairing nightmare. But the jaw isn't even the strangest adaptation, because the goblin shark hunts in near total darkness, at depths where sunlight doesn't penetrate, where vision is useless. So how does it find prey? That protruding snout, that weird fleshy blade extending from its face, it's covered in electroreceptors called ampullae of Lorenzini, thousands of them. Each one can detect the faint electrical fields generated by living creatures. Every time your heart beats, it creates a tiny electrical impulse. Every time a muscle contracts, electricity. The goblin shark can sense these pulses from meters away. It doesn't need to see you. It can feel your heartbeat through the water. Imagine being prey. You're hovering in the pitch-black abyss. You think you're safe because nothing can see you. Then suddenly, before you even know it's there, jaws erupt from the darkness and drag you into oblivion. That's what it's like to be hunted by a goblin shark. Before we dive deeper into just how wrong we were about this creature's habitat, behavior, and the disturbing question of how many actually exist, hit that subscribe button. Because what's coming next will completely shatter the living fossil myth. This shark isn't primitive, it's hyper-evolved, and we're only beginning to understand how terrifying its adaptations really are. So we've established the goblin shark has a projectile jaw and can sense your heartbeat. Nightmare fuel, right? But that's just the beginning, because for decades, we made one catastrophic assumption. This thing is rare. Museums displayed them as curiosities. Textbooks called them seldom encountered. Scientists estimated maybe a few hundred existed worldwide, deep-sea specialists, confined to narrow habitat ranges. Turns out we weren't looking in the right places. In 2003, fishermen off Taiwan reported a spike in goblin shark catches. Not one or two, over 100 specimens in a single year, all from the same general area, all at similar depths. Scientists started paying attention. They analyzed catch data from fishing vessels across the Pacific, Japan, Taiwan, Australia, New Zealand, and realized something disturbing. Goblin sharks were being caught regularly. They just weren't being reported because fishermen considered them worthless bycatch. No commercial value, weird looking, thrown back or discarded, which means for decades, we'd been systematically undercounting them. We thought they were rare because we weren't looking at the data fishermen were generating. When researchers finally compiled the records, the numbers were staggering. Goblin sharks aren't rare, they're cryptic. There's a difference. Rare means genuinely low population. Cryptic means we're bad at finding them. And goblin sharks are masters at being cryptic. They live at depths between 200 and 1,300 meters, the twilight zone and upper Bath Pelagic. That's below where most commercial fishing occurs, but above the true abyss. They're in the gap, the zone we rarely explore. Not shallow enough for divers, not deep enough for specialized deep-sea research, just in between. And here's the thing, that zone covers millions of square kilometers of ocean. If goblin sharks are distributed across even a fraction of that area, their population could be enormous. Tens of thousands, maybe hundreds of thousands. We genuinely don't know. But the habitat revelations get even stranger. Because while analyzing specimens, scientists noticed something odd. Goblin sharks from different regions had subtle differences, slightly different proportions, minor variations in coloration, different stomach contents. This suggests there might be multiple populations, isolated groups adapting to local conditions, which raises a disturbing question. Are we even dealing with a single species? In 2015, genetic analysis of goblin shark specimens from Japan, Australia, and the Gulf of Mexico revealed slight genetic divergence. Not enough to classify them as separate species, but enough to suggest these populations don't interact. They're separated by geography, by depth, by ocean currents, which means the goblin shark we've been studying might actually be several closely related lineages, each one slightly different. Each one adapted to its specific deep-sea environment. We don't know, because we've never conducted a comprehensive global population study. We've never tagged and tracked them. We've barely filmed them alive. Everything we know comes from dead specimens and a handful of brief encounters. It's like trying to understand human behavior by only studying corpses and watching a few seconds of surveillance footage. So let's break down exactly how wrong we were, because it's genuinely humiliating. Error 1, we thought it was slow and sluggish. Reality, its jaw strikes at over 3 meters per second. That's faster than a human can blink. The ambush happens so quickly that prey often doesn't react before it's already caught. This isn't sluggish, this is explosive precision. Error 2, we assumed it was a primitive, unchanged relic. Reality, it's hyper-specialized. That jaw mechanism didn't exist in its ancestors. It evolved over millions of years into one of the most sophisticated feeding adaptations in the shark world. Calling it primitive is like calling a stealth fighter primitive because it's based on aerodynamic principles discovered decades ago. Error 3. We believed it was extremely rare. Reality. It's cryptic. There are likely thousands, possibly tens of thousands, distributed across deep-sea habitats worldwide. We just don't see them because they live in a depth range we rarely explore and have no commercial fishing value. Error 4. We thought it was blind or near blind. Reality. While its eyes are small, it doesn't need good vision. The electroreception from its snout is so sensitive it can detect prey from meters away in complete darkness. It's not disabled, it's adapted perfectly. Error 5. We assumed all goblin sharks were the same species. Reality. Genetic evidence suggests there might be multiple populations with slight divergence. They could be in the early stages of speciation, or they could be distinct lineages we've been lumping together because they look similar. We don't know yet. And here's the error that haunts marine biologists. We assumed we understood its life cycle. We don't. We've never observed goblin shark mating. We've never seen a pregnant female give birth. We don't know how long they live. We don't know how fast they grow. We've examined juveniles and adults. But the transition between those stages? Complete mystery. One researcher described it as trying to understand human civilization by finding a baby's shoe and an elderly person's cane with nothing in between. Let's talk about something deeply unsettling. The skin. Goblin sharks are pink, not gray, not the camouflage pattern you'd expect from a predator. Pink, like exposed muscle tissue. Why? For decades, scientists assumed it was because they're deep-sea creatures. Down there, color doesn't matter. No sunlight. No need for camouflage. So evolution just didn't bother. Wrong again. In 2018, researchers analyzing goblin shark skin under microscopes discovered something strange. The skin has almost no pigmentation. It's semi-transparent. The pink color comes from blood vessels visible beneath the surface. But here's the disturbing part. The skin is also covered in tiny tooth-like scales called dermal denticles. These scales are arranged in a specific pattern that reduces drag and makes the shark hydrodynamic despite its weird body shape, which means the goblin shark's body is optimized for efficiency. Every part of its strange anatomy serves a purpose. The protruding snout isn't a deformity, it's a sensor array. The pink skin isn't a lack of adaptation, it's maximum efficiency with minimum energy expenditure. The saggy, flabby appearance isn't weakness, it's a neutral buoyancy that lets it hover motionless in the water column without wasting energy. This shark is a masterpiece of deep-sea engineering, and we called it primitive. But the most disturbing revelation came in 2021. Researchers examining stomach contents from multiple goblin shark specimens found something unexpected. Plastic, microplastics, in almost every shark examined, even ones caught at 1,000 plus meters depth. Which means human pollution has reached the goblin shark's habitat. The deep ocean, the place we assumed was too remote, too deep, too isolated for our trash to reach. We were wrong, again. And if microplastics are reaching goblin sharks at 1,300 meters depth, what else are we poisoning that we don't even know exists yet? So why does this matter? Why should we care about a pink nightmare shark that lives in the abyss? Because the goblin shark is a perfect example of how wrong we can be when we assume we understand something. For over a century, we looked at this creature and saw a primitive relic, an evolutionary dead end, a curiosity. We never questioned that narrative because it fit our assumptions about living fossils. Then we actually studied it, filmed it, hunting, analyzed its genetics, compiled catch data, and realized we'd completely misunderstood what we were looking at. This isn't a relic, it's a specialist. A predator so perfectly adapted to its environment that it hasn't needed to change in 125 million years. Not because it's primitive, because it's already optimal. And here's the thing that should terrify us. The goblin shark lives in one of the most poorly explored regions on Earth. The mesopelagic and upper bathypelagic zones cover millions of square kilometers. If we were this wrong about a creature we've known about since 1898, what else is down there that we don't know about? What other primitive relics are actually hyper-evolved specialists we've completely misunderstood? The ocean is not empty. It's not mapped. It's not understood. And every time we send cameras into the deep, we find something that rewrites the rules. The goblin shark is real. It's been hiding in the gap between shallow and deep, between explored and unknown. For 125 million years, it's perfected the art of being invisible. Not because it's rare, but because we're looking in the wrong places, at the wrong depths, with the wrong assumptions. We were wrong about its speed. Wrong about its rarity, wrong about its specialization, wrong about its habitat, wrong about calling it primitive. The only thing we got right? It looks like a goblin. And it's absolutely terrifying. But here's the final twist, the most unsettling realization of all. We've photographed living goblin sharks maybe 50 times. We've captured live specimens you can count on 2 hands. We've filmed hunting behavior for maybe a few minutes of total footage across all encounters. Everything else, the population size, the life cycle, the mating behavior, the true habitat range, is educated guesswork based on corpses and scattered data points. Which means everything I just told you represents maybe 5% of what there is to know about this creature. The other 95% still down there, still hunting, still hovering in the dark with that horrible protruding snout, sensing heartbeats, waiting for prey to drift too close. And somewhere, right now, at 1,000 meters depth in complete darkness, there's a goblin shark we'll never see, never catch, never study. It's been hunting the same way its ancestors did 125 million years ago, not because it's stupid, but because when you're already perfect, why change? Sleep well.